the greenest energy is the energy we don't use. So a green solution is a solution that don't use energy. That can maybe be a bit boring depending on what you want to do, not using energy at all. So a green solution should also be a solution that uses less energy, or maybe is capable of running on renewable energy sources, such as electricity. With 400 megaton of CO2 emissions, international aviation is a large and well-known CO2 emitter. What is green solutions for traveling? Well, a green solution for traveling could be to take a walk. We don't get that far, so maybe we should look for another technology. A technology that can run on electrical energy sources that could be renewable. We could take the train, or we could just go very green and stay at home. 400 megaton, that's quite a lot for international aviation. There's a lot of fuss about it. Should we fly? Should we stay at home? Take the train? Take the bike? Another industry that emits an equivalent amount of CO2 is construction machinery. So what is the green solution for construction machinery? We could stop building. We could go the old-fashioned way, pick up the shovel and start digging. Or we could try and do the same as with the train. Look for energy sources that can drive our machinery on renewable energy. Today that looks a bit like this. Small mini excavators that can be run on electrical energy sources. And it takes far too long time to build what we're trying to build. So what we need a green solution for is this one. A large-scale excavator. And in 4 minutes time I'll give you that green solution. But before we do that, let's look into this excavator and see why is this not green. A small numbers game. We put in 8 energy units to our excavator. We are positive on the diesel engines and say that they have efficiency of 50%. That means that 4 energy units are lost in the diesel engine. Then 4 energy units come through to the fluid power system, and 1 out of these 4 go to real work. The last 3 is wasted in the hydraulic system as heat. Heat that we don't really need with global warming and all that. But why is it that 4 energy units coming into the hydraulic system, 1 real work, 3 heat? The reason is that our hydraulic systems are run and controlled by valves. So we use valves to control hydraulic systems, and doing that is the same as using this technology. So using valves is the same as using brakes to control your hydraulic technology. Small example with our excavator. The excavator has 3 cylinders, 1 for the boom, 1 for the arm and 1 for the bucket. Then we have a hydraulic motor to swing the excavator. The diesel engine supplies mechanical power to our hydraulic pump, which make power into fluid power on our high pressure line indicated here in red. Then we have low pressure return oil on the blue one. Our actuators then need some fluid. Out of the high pressure line we control how much goes to each actuator at which pressure level with our valves. So it could be that we have 300 bar at our high pressure line and our cylinder in the middle needs 100 bar. And then we throttle 200 bar away. We break 200 bars away. And a way to illustrate it is a bike. So we're pedaling on the bike, going fast, and then if it goes too fast, we pull the brake. If it goes too slow, we release the brake. That's how we control hydraulic systems. And for a small example, if you go downhill then on the bike, at some point it starts to go too fast. Then I pull on the brake because I don't want to crash. But while pulling the brake, I'm still pedaling. I'm still putting energy into the system while breaking away energy with the brakes. And that's stupid. But that's how we run our hydraulic systems today. For an excavator or crane arm, that could look like we have a load high up in the air and we want to lower it. While doing that, we are throttling energy away across the valve. We're breaking energy away while the pump is still running, putting energy into the system. So we're supplying energy to lowering a load. And that's plain stupid. We should do something else. And what I suggest we do is we make a component that we put in here that has the capability of taking out fluid from the high pressure line at, let's say, the 300 bar, then transform the pressure level to what is needed inside our actuators without losing energy, without throwing energy away. So we're simply taking the amount of energy that we need, transforming that to the pressure level we need, and sending all of that out to our actuator. And maybe this component should even be able to take power or energy from our actuator at a low pressure level, transform that into a higher pressure level, supply that back to our high pressure line, such that we can use it for later or in one of the other actuators. So this hydraulic transformer is a transformer that we made with two words in mind: simplicity and efficiency. It should be simple, such that it's easy to make, easy to repair, and cheap to produce. Efficiency still needs to be high, even though that we change the system architecture to being a system that is not depending on braking or resistive control, but transformer based. The transformer needs to be efficient, such that we don't throw away all the energy in the transformer. So what we have now is a transformer that is simple in structure and have clever control. And with that transformer, let's have a look at our small numbers game from before. The standard excavator, 4 energy units into the hydraulic system, 1 to real work, 3 waste of energy. With our transformer, still the same amount of work that we do, but now only 1 of these being waste. So we only put in 2 energy units to our hydraulic system instead of 4. So we significantly lower the amount of diesel that our diesel engine needs, significantly lower the CO2 emissions from our machine. And yes, I know another way to lower the CO2 emissions is to use a renewable energy source like electricity. So why not make a electrical excavator? Borrow this from Volvo. An electrical excavator has a runtime 4 to 5 hours. That's nice. It's running on electricity. If we have enough green electricity, this is very nice. However, if we put in a transformer in this system, we could change the numbers from 4 to 5 to be 8 to 10. And we know that production is king in industry. We don't want to wait 1-2 hours to recharge a battery before we can start excavating again. So with an efficient hydraulic system, we can run for longer time on the same battery, or we can make the same amount of work on a smaller battery. That's up to the construction machine manufacturers. So let's sum up a bit on the hydraulic transformer. Using this hydraulic transformer to improve efficiency, we lower the fuel costs, we improve the runtime on electrical machinery, we have inherent health monitoring in our system, and then finally, the last one. Before we had 3 energy units of heat, now there's only 1, meaning that the cooler can be significantly downsized in our system. So this technology really brings a lot of positive forward. But how do we get it into future fluid power systems? That's a good question, because nobody knows about it. How do we get people to use it to make a greener future for fluid power systems? How do we get people to buy something they don't know what is? So what we're doing in HyNeron is that we're going out to potential customers, getting to know the machine, getting to know how are the hydraulic system today, put that into a computer, making a model. So now we have a simulation model of the system. With that simulation model at hand, we do energy mapping, potential assessment, concept development. We can look at how can we improve customers' machines to be energy efficient and run for longer time on the same battery. While doing that, We can do that for construction machinery, but we don't want to stop there. All future fluid power systems should be energy efficient. So whether it's in construction machinery, production industry, or maritime, all of it should be energy efficient. So the goal for HyNeron is to lead fluid power technology into a greener future, and we hope to see a lot of you there.